Now let's try to understand with all those tensors, what will actually happen when you're actually building your neural network or your convolution neural network, how the computation is being done. Okay, you're just importing the torch library. You create a variable, which is like a matrix true cross true. Let's say this is your input variable. And let's say you have another variable y. Again, it's 2 cross 1, which means it's just 2 different values. Another variable, so I will just quickly go through what these variables are. So let's say this is your simple neural network architecture. And the idea is X is your input data, which is defined by this variable over here. And W is the network weights, all right, defined by this line over here. You can see that there's an argument like requires grad equals to true. This means that this actually is an acronym for require gradient. When it is true, which means that this is like a learnable parameter, and this is a parameter of a network, okay, because these are weights. And X and Y are not, because this is like data, which will flow in the network. So you're multiplying X with the weights, all right? And that will give you A, and B here represents the biases. So what you do, like the normal neural network formulation, if you write the equation, that should be like, if Y is your output, then that Y should be equals to X times the weights, and then you add the biases to those. So this is like a very simple formulation for a neural network. And if you write this using PyTorch, you'll have to define all these variables, okay? And then you can just write one line code over here. So this is torch dot matrix multiplication, which means like you're multiplying X with the weights, plus you're adding biases, and then you're applying like the sigmoid activation on this output, and that's going to give you the P, which is the network's prediction. So this simple one line actually defines a neural network for you. Okay, so pretty simple. Then the next part is you need a loss function, and again, don't worry about like this complex equation here. We'll talk about like loss functions later. So this is a simple cross entropy loss. I think we have seen this equation before, so it might not be difficult to understand for you. This is the same formulation, same equation. So loss in this case will be, that this is the ground truth, this is the prediction, and again, this is the ground truth, this is the prediction. All right. You can just write the loss function here. And your cost will be, you just average your loss, because if you have, let's say, 10 samples, you will compute the loss over all these samples and take a mean, okay? And then you have to minimize this cost to train this network. Okay, so let me put all those three over here. So this is your neural network, which is taking X as input, W are the weights, B are the biases, and again, B are kind of weights as well. And this is giving you the loss function. So based on this prediction and this ground truth, you can compute the loss. You're just averaging the loss over multiple samples. Then what you do is you just do a backward call. Again, this is a library function provided to you by PyTorch. And all the chain rules we studied, the backpropagation we studied, everything is being taken care by this single function call. So you don't have to create compute gradients. You don't have to perform like those simple steps. Everything will be taken care by this simple function. So what this function is doing is, it will take this loss value and it will compute gradient for all the variables in your network. Okay, and basically it will compute the gradient one by one, right? And it will use the chain rule to go backwards. And once you run this backward, then you can see like what is the value of the weights and what are the values of the biases. So when you train this thing over different samples, these values will be changed. All right. And of course, like Y is your ground truth, so you don't have to worry about that. You will provide that to train the network. And X is again your training sample, so you will provide that. So the only thing which is being trained is the weights and the biases. So this is like a very simple formulation, how you can train your a simple maybe neural network using PyTorch. But again, you can easily generalize this to like your more complex CNNs which you are going to develop. But of course, that process is not going to be this complex. This was just to give an idea like how this can be done very easily with PyTorch.